Welcome to the part 2 video where I'm showing the experiments that I normally carry out when I'm teaching the topic on length and time to the IGCSE students. Now on number 4, which is finding the circumference of the test tube or of a test tube using a fine thread. So I've got a thread here and I've got a test tube. So I'm going to wrap this thread around the test tube 5 times, then divide the length of the thread by 5. Right? So that's 110, 2, 3, 4, 5. Right, so here we are. So I'm going to hold the ends like that. Alternatively, I can mark where the two meet, right? So I mark here and there. Make sure I produce visible marks. See here and there. Okay, fine. Right, I'm going to put the thread on top of a millimeter scale and then see what you're going to get. And this is 25.9 centimeters. And then I'm going to divide this by 5 because I've wrote it 5 times. And then find the average. Therefore, the length of 5 times the circumference is 25.9 centimeters, and the circumference becomes that divided by 5. So 25.9 divided by 5 centimeters there. Which is 5.18 centimeters. Right, so I'm going to prove the answer that I found here by using the vernier. So with the vernier, I'm going to measure the diameter, the external diameter of the test tube, and then I'll use the formula circumference is equal to pi d, and then compare the two values of the circumference. Right, measuring the external diameter on the vernier, this should be 1.57 centimeters. Right, now inputting it on our formula, we have circumference being equal to pi times 1.57 centimeters, which is 4.93 centimeters. Now this gives a difference of about 0.25 with the circumference that we found with the thread. Now from here there's a question which says, why is this method not accurate? Apart from many other reasons, this thread itself can stretch. Okay, so which means it gives us a false reading, especially when we wind it around the test tube. Now the fifth and the last experiment that I normally carry out is finding the circumference of a disc. So I'm going to take a disc and then roll it on a millimeter scale of a ruler until it makes one complete revolution. And then from there I determine the circumference of that disc. Right, so I'm going to mark a position here. That's going to be our reference point on the disc. And then I let that mark, let's start maybe at 10. Let's position it this way. So at 10 there we are. Then we roll it until that position comes back again on the millimeter scale. So be careful to make sure that I run parallel to the position where I started on the meter row.
So I've moved a bit here, back. So that gives me 35.8. 35.7. 35.7. So, right, from 10 to 35.7. Find the difference there.
Right, I've recorded my readings here. The final reading was 35.7 and the initial was 10.0. So the difference is 25.7 centimeters, which is the circumference of the disc. Obviously, this method has got its own limitations. As you saw, when rolling the disc along the scale, the disc may slide over and then you get a wrong reading at the end. So care must be taken in rolling the disc so that you keep it parallel to the meter where it started. So I think this is the end of the experiments that I normally carry out. Please make sure you subscribe, you like, and then you share the videos.